Welcome to homework.
So now we'll work on problem 94 from chapter 6. In this problem, we're told that Bohr's model can be used for hydrogen-like ions that have only one electron, such as helium plus or lithium 2 plus. So the first question they have is, why is the Bohr model applicable to helium plus ions but not to neutral helium atoms? So this Bohr model is applicable for one electron systems. Helium, neutral helium has two electrons, so Bohr's model does not apply for that. But the helium plus ions have had one of the electrons removed, so it only contains nucleus and one electron. So in part B, we're given a table which we can go ahead and reproduce here. So we have ground state energy, and then we have this for hydrogen, helium plus, and lithium 2 plus. And the ground state energies for hydrogen is negative 2.18 times 10 to the negative 18th joules, negative 8.72 times 10 to the negative 18 joules for helium plus. For lithium 2 plus, it's negative 1.96 times 10 to the negative 17 joules. So we have this trend here, and the question in part B is, by examining these energies, propose a relationship between the ground state energy of hydrogen-like systems and the nuclear charge Z. So we could say that as Z increases, nuclear charge, which goes from 1 to 2 to 3, as Z increases, the ground state energy will increase as well. So in part C of this problem, we are asked to use the relationship derived in the part B to predict the ground state energy of the carbon 5 plus ion. So we can see, we could approximate that based on the fact that as we're going from a nuclear charge of 1 to 3, the ground state energy increases by about 1 times 10 to the minus 1 unit of joule, 1 joule, or by 1/10 of a joule. So we can see it increases by a factor of 1, roughly -2, roughly -2, so times 10. So to increase from a nuclear charge of 1 to a nuclear charge of 3, now we have a nuclear charge of 6. So since we have a nuclear charge of 6, it should be roughly 8 times 10 to the 15th. So if we go from 1 to 3, and if we go to 5, it will be about 2 times 10 to the 16th. 2 times 10 to the 16th, and then it'll increase by about a factor of 5, so it should be 8 times 10 to the 16th power, negative 16 joules.